Right. Okay, all of you, can you type in if you have a
Excuse me,
doubt that till we have done here?
excuse me, sir.
Yes. Chitranshi, please tell me.
Sir, can we solve it by solving the equations or without
Ha,
putting the value?
nahin. We can solve it in many ways. I'll come to that. I'm just putting in a value for so that we understand how those ways have come. Okay.
Okay,
That,
okay,
that
sir,
is
okay.
a very quite easier method of solving this. So we'll come to that. In the next 5 minutes, you will get to know that. Okay. Right. Okay. So guys, assuming that you have understood till here, this is where we are now. I'm now going to proceed further. So if you look at this entire statement, this question was asking about a number which when divided by 3 leaves me a remainder 1, and when divided by 5 leaves me a remainder 1. Now this is a set of numbers that I have got which leaves a remainder 1 when divided by 3, and this is a set of numbers that I've got which leaves a remainder 1 when divided by 5. Now your ultimate aim is to find numbers which satisfy both of these conditions. So both conditions means that it should be existing in this list as well as it should exist in this list. So if I look at this, 16 is one such number, 31 is second such number, and I'm now sure that there are many other numbers that is going to follow through, right? There are many numbers that's going to follow, right? So now let's look into this. Why are these numbers 16 and 31 falling into this place? Because when I'm looking at a number that is divisible by 3, giving me remainder 1, divisible by 5, giving a remainder 1, I'm actually looking at a number which is first divisible by 3 and 5. Okay? And what is a number divisible by 3 and 5? It is a number which is divisible by 15. Right? Any number divisible by 3 and 5 means that the number should be divisible by 15. LCM basically. And now, so I am looking at a number which is divisible by 15. So 15 ka multiple. Okay? Because all numbers which are multiple of 15 are divisible by 15. After that, beyond that, I am looking at a number which leaves me a remainder 1 in both the cases. So I am looking at a number which is 1 more than this in both the cases. Now when I place k value as 1, what value do I get? 16. When I place k value as 2, what value do I get? 31. Right? And so on and so forth. Thus, this concept, right, this model, we call this as an LCM models because LCM is what comes handy in solving these kinds of questions. So if I want to generalize this, right, if I want to generalize this and get into a format, let me, I don't want you guys to write down anything from here right now, just listen to me carefully. So let's say that there is a number and I am dividing this number by p. And when I divide this number by p, I am getting a remainder of r. Okay? And I divide this number by, let's say, q. And when I divide this number by q, I still get a remainder r. And let's say that I'm dividing this number further by s. And when I do that, I still get a remainder r. Okay, and no matter how many other numbers I divide by, I end up getting r as a remainder. So do you recognize what's unique thing about this? The unique thing about this is the remainders are same for all the divisors. Okay? If that is the kind of a question that is thrown to me, then the number will always be in the format of LCM of your divisors, okay, into, let's say, k plus r. Okay, the number will always be in the format of LCM of your divisors into k, because if you look at this slide here now, it was 15 and its multiple, and that's why it was 15 into k, right? I knew that the number is 15 or its multiple. So similarly, the number is an LCM of PQ and S, or it is its multiple. And once I find that, I have to add R to it. And how do I find the multiples of these values? When I take an LCM of P, Q, and S and start placing K value as 1, 2, 3, and so on and so forth. Did we all understand? Chitranshi, is this right? Is this fine?
Yes, sir.
Great. Stuti, is this what you also did?
Yes.
Absolutely. Right. So I hope you guys are clear with this. If that is the case, then don't come into any other question right now. There are other caselets also. So if you're clear with this case, can you try solving this question? All of you. Find the largest 3-digit number which when divided by 3 leaves a remainder of 2, and when divided by 5 leaves a remainder of 2. Okay, so before you guys get into the largest, so the question I'm changing the question for a minute, just hold on. Before you guys get into the finding the largest 3-digit number, can you type in the smallest, okay, the smallest number that falls in this category? Let me see if there is even a single person who will get it right. Okay, the question is not the largest 3-digit number. The question is find the smallest number which when divided by 3 leaves a remainder 2, when divided by 5 leaves a remainder 2. I am waiting for people to give me the correct answer. Stuti, okay, Hema, Preeta, Kritika, Akriti, Chitranshi. All right, great. Nice.
Are we talking about the smallest positive number or the
Yes.
smallest number?
I'm talking about the positive numbers, Stuti. Okay, right. So many of you wrote 17 as a number. 17 is not the right answer, okay? Because 17 is not the smallest. Yeah. I have to divide a number by 3. Yes, Karen, k can be 0. And get a remainder of 2. Tell me this, guys. Ananya, I'm not looking at the smallest, largest 2-digit number. I'm looking at the smallest number, right? So when I divide 2 by 3, what is the quotient I get here, guys? 0, 0. What is the remainder? 2. Please understand, when I'm dividing a number, the quotient can be 0. Okay? There is no rule of of divisibility in that case. You know, when I mean the questions like, when do we say a number is divisible? We say a number is divisible when it does not leave any remainder. Okay, that's when the number is divisible. And the quotient should be an integer. That's very important. Okay, so I cannot write the quotient as 1.5. So quotient has to be an integer, And I can always say that a number is divisible when the remainder is 0. So if I'm dividing a number by, let's say, 3, and if it's giving me a remainder of 2, then the number can be 2 itself. It need not be 17. Okay, clear? So now let's first, before that, get into this. So I'm dividing by 3, leaving a remainder 2, dividing by 5, leaving a remainder 2. So what is the format of my number? Format of my number is LCM of 3 and 5, which is 15, its multiple, plus the common remainder that we have. So 15k plus 2 is my format of the number. Okay. When I start placing k value from, when I place k value as 0, that's when I get the smallest number. As long as, remember, as long as the number is positive. Okay. When I place k value as 0, I get the smallest number. When I put k value as 1, I get the next number. And so on. When I start placing k value, I start getting different varieties of numbers. Now, the question, coming back to the question, right? The question said, find the largest 3-digit number. I know that the largest 3-digit number is 999. So I am now looking into a number, right, which is Nehali, you have sent me the smallest 3-digit number. We are looking into the smallest number as such. Okay, but it can be a single digit, or it has to be a single digit, or a single digit or a double digit, but the smallest. Now I'm looking into the largest 3-digit number. The largest 3-digit number is 999, right? Now, but I am looking into a number which is a multiple of 15 and then plus 2. Okay. Now, my observation, so this can be done through observations, but if you want, you can do this for all of you who are not, for those who are not that great in maths. The way I will do this is, I'll take 999, divide by 15. I know that 15 6 are 90. I take a 9 carry over, 99, 15 6 are 90. I get a 9 remainder. Means what? 999 when divided by 15 gives me a remainder of 9, means 990 is divisible by 15. That's what it means. So if I remove this remainder from 999, I get a number which is divisible by 15. Now, so if 990 is divisible by 15 and I am looking at a number which is 2 more than that, my number that I'm talking about is 992. This becomes my largest 3-digit number that is divisible by 3 and by 2, 3 and by 2, and by 5, and leaves me a remainder of 2. Are we all clear with this question? Type in a yes if you are clear with this question, guys, because most of you, almost everyone's video is off, so I can't see anyone around. So I don't even know whether you exist. All right. Thanks. Yes, any doubt? Someone has a doubt?
Sir,
Any?
can you repeat this one, sir?
Which one? Which one?
3-digit number. 3-digit
Smriti?
number.
So I wanted to find the largest 3-digit number. Okay. So Smriti, which is the largest 3-digit number in our number system? 999. Yeah. But what I have to figure out is, or what I have to see is, I have to see a number which basically is 2 more than a multiple of 15. So this is a kind of a number that I have to see. 2 more than multiple of 15. So first I have to see is closer to 999, which is the number divisible by 15. That's what I have to search first. So I will first take 999 and divide by 15. When I divide by 15, I get a remainder of 9. What does it mean? It means that 999 is not divisible by 15, but 999 minus 9, the remainder if I remove, right? 999 minus 9, this value is divisible by 15. That's what it means. So what is 999 minus 9? 990. So this number is now divisible by 15. Okay, Smriti? But now your question is not about a number divisible by 15. Your question is a number which is 2 more than that number, because that's why that plus 2 is here. Okay. So you are searching for a number which is 2 more than this. So what is 2 more than 990? 990. So this is the answer for this question. Are we now clear? Okay, someone said 997 is also possible, sir. 997 wouldn't be possible. How is it possible? 997 means, okay. So if someone has posted in the group that 997, Ananya, right? 997 is possible. So Ananya, if 997 is possible, if that is the number falling into this spread, it means that when I'm dividing this value by 15, it should give me a remainder 2. Does it give me a remainder 2? No. Because if you see, when I divide this number by 3 itself, 997, when I divide by 3, Ananya, I get a remainder of 2. Oh, sorry, a remainder of 1. Use 3's divisibility rule. What is 3's divisibility rule? Sum of the digits. 9 plus 9, 18. 18 plus 7, 25. When I divide 25 by 3, what is the remainder? 1 is my remainder. So if I am dividing 997 by 3, what is the remainder? 1 is the remainder. But in the question, what is the remainder that you want? You want a remainder of 2, and thus 997 cannot be your value. I hope you are clear, Ananya, right now. Right, guys. So I think I will be stopping here because there are anyway 2 more models to go, but I don't want to force you into these 2 models. Okay. Typically what happens, guys, that when I'm teaching for higher exams like the MBA entrance examinations or any other competitive challenging, much challenging quantitative exams where or maths is dominating the exam pattern, there I finish this concept that you learned now. I usually finish in 15 minutes, 1-5. Okay. The fact that I have spent more than 50 minutes for this was because I do not want you guys to feel that this is complicated and hence leave out solving such questions. I presume that you all have understood solving this pattern. The next pattern that's going to come is, so if you realize what has happened in this pattern is, we have taken R as same, right? Everywhere it is leaving the same remainder. But there can be a pattern where my remainders will start changing. So what if I'm dividing by P and my remainder in this case is, so let the question be, for example, let's say I'm just giving a question that dividing a number by 5, my remainder is 2, dividing by 7, my remainder is 4, dividing by 9, my remainder is, let's say, 6. Do you realize that here my remainders are changing, right? So if my remainders change, then what should I do? Okay, so there are other patterns also which we will get into, but as of today, I think this is sufficient. If you guys have any kind of a question, doubt, feel free to throw, or I'll assume that you have understood everything. Tell something at least, type something at least. Let me know what exactly it is. Oh, Sonali, this batch, when did this batch begin? I don't know when this batch began, but then We just started numbers classes. I have probably done 3 classes of numbers. You can get back, go to those classes which is there in the YouTube, right? And see. Rimjim can share the YouTube link in this space for those who
Yeah,
are unable to.
guys, you can just go on YouTube, go to Ignite India Education, search that channel. All the videos are listed there of yesterday and today will be uploaded by tonight, I guess. So please check the previous classes if you have missed that. And that's how we'll be continuing. For today's class, if you have any doubts, just post them on the chat box.
Right, and I have also floated my number. If you guys have a, oops, I'm so sorry. Suti, sorry. So I am posting my number. If you guys have any doubts, please, you are free to connect and ask. Now, please understand that many of you would like to have certain practice questions. I am not interested in giving you practice questions right now. I'm interested in you understanding the concept. Over the period of time, when we are closing down to numbers, we will surely sit and solve questions, okay? And I will be solving at least 2 or 3 test papers with you. Test papers in the sense, papers which contains questions we will solve so that we understand all the concepts and there is a revision of all the concepts that happens, okay? So don't bother. In case you are so very desperate to solve questions, connect to Rimjim ma'am. She has certain materials which she can forward it to you and you can do that. My advice is take it light, take it simple. You will conquer, don't worry, okay? So those who have missed out all the previous classes or any of the previous class, or those who have confusion of any of the previous concepts, please revise. So that's important, right guys? So we will catch up soon and continue the other 2 models. So that I'm going to take it a bit faster. This I wanted to take it a bit slow because it was a basic of understanding. But now you have understood this, the other 2 concepts can grow faster, right? That's all, guys. I presume no doubts, Rimjim. So we
Yes.
can bid bye.
Okay, guys, thank you for being here. Thank you, Anand sir. Please like, share, and subscribe the video which will be uploaded on YouTube for this class and for the previous classes. And please help anyone who is in need, like spread the information. And thank you so much, sir. Thank you, students. We'll see you in the next class.
Thank
Bye.
you. Bye-bye. Good night.